So here in this problem, we need to transform the Cartesian coordinate -3 over square root of 2, comma -3 over square root of 2 into its corresponding polar coordinate. Now, let's first begin by plotting the point on the Cartesian plane. So here we have 3 over square root of 2. Now square root of 2, that has a value approximately 1.414. So if we divide 3 with square root of 2, we get a value somewhere around 2.12. So we'll consider it to be approximately 2. So that means we have to plot the point -2, -2. This is only for guidance. So that means since both the x and the y coordinate are negative in nature, so we're going to lie on the third quadrant. So here we have -2 on the negative x-axis, and then we go -2 units along the negative y-axis. So this is going to give us the point -3 over square root of 2, comma -3 over square root of 2. Fine. So our goal will be to convert this Cartesian point to its corresponding polar coordinate. Now let us begin. Our first goal will be to join the point P and point O. This is going to give us the radius R. So here, radius R, which is the line OP, that can be simply obtained by using the distance formula. All we have to do is take the square root. Underneath the square root, first we'll have to consider the x coordinate. So that's -3 over square root of 2. We're going to square this value and then add it to the y coordinate -3 over square root of 2. We're also going to square this value. So this gives us, we have square root of 9, that's -3 squared is 9, divided by 2 plus 9 divided by 2. So that gives us square root of 9, which is going to be equals to 3. So we have found out the value of R. So this is going to be 3 units. Next, we need to find out the angle. For that, what we'll do, we'll drop a perpendicular from point P on the x-axis, and let's say that a line meets at the point A. So PA is going to be perpendicular on the x-axis, and we get a triangle, right angle triangle PAO. So let's consider in the right triangle PAO. So it's right angled at A. So here we'll try to find out this angle, and we're going to name this angle as phi. So we'll take the tangent of this angle phi. So tangent of angle phi is going to be defined as the y coordinate, which is AP, divided by the x coordinate, that's OA. And what we'll do, we'll take only the magnitude. So we have AP. AP length is 3 over square root of 2 divided by OA, so that's also 3 over square root of 2. This comes out to be equals to 1. So we have tangent of phi equals to 1, and we know that whenever phi is 45 degree, we get our tangent value of 1. Tangent 45 equals to 1. So that means this phi angle, it comes out to be 45 degree. But our goal is to not find out the angle phi. We always have to find out the angle which is measured with respect to the positive direction of x-axis. So this is the angle phi theta that we are talking about. Either it could go in the anti-clockwise fashion, or it could go in the clockwise fashion. So this could be also another instance of theta. So let's try to find out the two thetas. Both would mean the same thing, only the direction is different. So if we are considering the theta angle, so this is what. First we start from the positive x direction and rotate by an angle of pi radians. From there, we move an extra amount of phi radians. So theta is going to be pi plus phi. So phi, we obtained that this value is 45 degrees, or pi over 4 radians. So that's 5 pi over 4. Now that means the point P can be also expressed as the radius, which is 3 units, and the angle theta is going to be 5 pi over 4. So this is one way. And if we go the other way, that means in the clockwise fashion, then theta will be defined as, so all we have to do is we take pi radians, and from it we subtract the angle phi. So this is going to give us the theta measure, but then again we are going in the clockwise fashion, so we'll have to consider negative value of theta. So we have negative times pi minus pi over 4, and the value comes out to be -3 pi over 4 radians. So this is another way of representing the given point in the Cartesian form in the polar coordinate as 3, -3 pi over